Hey, Steve with Trimble, and in this video, we're going to show you how to align some scans to an existing model. In this example, we have some scan data of an existing structure that they're going to add on some new steel coming off of here. We're going to QA/QC that these fittings are going to fit and were essentially installed correctly so that the steel that comes in after is going to fit. Um, you could use the scanner and actually resection it and place it to control. This example, we're going to show you just how to manually do it. So I will go to scan register. I could do this on the first scan or really just grab the parent scan, which in this case is indicated by that star number 2. If I grab another one, it's going to be registered, so I'm going to have to break that to move it. But if I want to move them all, I go to that parent scan, and then what I can do is start to grab it and move it. So this is field link. This typically runs on the tablet. You can do this on the tablet as well. But what we'll do is start to place this. So we have existing steel, so we should match those. And we're going to actually try and also align this to some concrete that's inside here. So some of these other scans actually have a better view, maybe not that one, of this pad that's in here. So we're going to actually make that 0. But yeah, we're going to go ahead and go back to register and start to try and align this to that model. So first thing I usually do, and what I'd always say everyone should try and get used to using, is that section box. Because what that allows me to do, and I have a couple of these already made, is just focus in on the steel area. So I will come in here and drag this down to make sure I'm aligning that correctly. So I'm going to look at just the area that I want to align really well, which would be this existing steel that's there. And the other tool that's really useful here is the ability to change the USC, kind of the scan center, what I'm dragging to align. So I'm going to bring this in, fit this side, and then if I have a mouse with the zoom wheel, I can do this on the tablet or I can do this in Field Link Office. All I'm doing is clicking and holding and then rotating and trying to make sure my azimuth is correct. So I'll do this a couple times. Yeah, you're actually going to see in this video, I'll do this a few times to make sure I'm aligning it correctly. So here I can see we have some existing, and this looks a little busy because I'm looking down the whole side. So what I'll do is bring this guy in and just align it to this first one. So now when I go to this side view, I can see there's the existing right there of what it's tying into. And then I'll probably run down the line and make sure all those are going in. This is a 1 point kind of alignment. So if there's a rotation, I'm kind of stuck with what it is, but I can get it pretty close doing this. And then as I go through this, we'll run an inspection. So we'll speed this part of the video up, and then we'll come back after I like the alignment. All right, so checked a few of those. Actually, I liked them pretty well. My next thing I can do is actually go all the way down, bring in the full density. So on Field Link, we're only going to display the preview point cloud. I can bring the full density, and that just allows me to check it better. So I can really see if I'm within a quarter inch, eighth inch of uh, where that design location is. So really, I'm just looking at these guys to make sure they're all good. And you can see we still have a bit of a rotation error here, or I need to rotate a little bit more. So I'm going to go back and do that again. Bring this guy back in. And actually what I'll do is really precisely bring this in. And only look at that. So I'm just using the view to kind of move that around a little better so I don't have to see all this other stuff. So again, what I was trying to do there is just focus in on this kind of where the steel attachment is. And then if I can line this up, I can start to see there how I can align that azimuth. Now, this is a real easy way and kind of something you do after the fact. If I could set this up on control, I would set the scanner up and just measure 2 control points with 1 scan and then tie the rest of them in. That'd be a more precise way to do it and have a setup error, which would be preferred, but this is after the fact and can still be very useful because obviously aligning it will show me if there is an offset. If there's a large offset and I determine it's not the azimuth, then really where those were installed was not where they were designed. So you can still use it as evidence because between the scan data, it's still going to be very accurate. So um, there we can see that looks actually very nice. All those are going in very well, and that's where the steel will go in. If I didn't have any scan data initially, I could also place some markers, or if I was closer to something, I could create points that I could come back later. Like if these were here, I could create a point, export my scan data, design back in what I was going to build, and then use that point and hopefully like one other to set up my total station to lay out the anchor bolts for the new steel that's coming in. If I wanted to do very accurately, I would place some checkerboard targets, just black and white checkerboards that would hopefully be semi-permanent so I could see them later, and then search for a target and it'll find right here. I'd click on it. It would add a point to it as well too. It would add that as a control point that I could then design in some new steel or really any, if I'm working in MEP space, anything there. And then I can use that to set up my total station to line to later. So that's in the station view. For the points, I could actually do it on the outside too. I can come in here and essentially click on one of these points and use that. So that'll create a 3D point. So working backwards or continuing forward, actually, I would have this aligned. The next thing I actually want to check before I say I'm done is I wanted to align this concrete floor back here. So what I'm doing here, I wanted to make that concrete floor 0 just as a reference elevation. Easiest way to do that, just because it's not really clear which one it is. I'm gonna do a little bit of a subsection of just kind of, you can see it's a pretty busy shop, stuff on the ground. I'm gonna try and find the best entrance. And so I'm gonna bring in a little bit more detail and change this to elevation view and change my reference elevation to 0. And you can see right here, this is just showing me that's actually, with that aligned, is already pretty good. So it's an 1/8 inch. I would want to have a mark on the floor so that when I come back, I would know like this area, that concrete is 0. Obviously, an existing structure, you're going to see it move quite a bit. And even right here, you can see it's higher, probably sloped down so that if water got in and zoom away. Reference elevation is probably better off as either a pin in the ground or a mark on the wall, a 4-foot mark, 5-foot mark, so that I know what I'm pulling to. But that actually already looks good. So with that, I can come here and roughly check my alignment pretty quickly by doing a couple things. One is I can come in here, let me make this a little bit bigger, and run an inspection. We'll see if that works. By going to scan inspection, the scan and model are aligned, and then I will hit this to actually compare the scan data to all the model data. And that actually ran pretty quickly. So anything in gray, and I can change this, is outside of 2.5 inches, but I can take that down and see that all this things that are hanging out are within uh, actually about perfect, or 0 inch. If I wanted to make this tighter, I could change this tolerance to 2 inch. This is just showing me that the alignment there is good. And where I may have an issue right here with one of these hangers being, or connection points being off a little bit more than 1/4 inch. I can inspect that again later. So that show me that's good. Now, I've aligned this well just manually. Again, we talked about how to do it a little bit more accurately with some points, georeferencing or resection scanner, but I'm happy with this is. And from here, I can actually, let's turn this guy back on. I can export this data, and I'm going to make this a little bit bigger just so you can see everything. I can export the inspection cloud, and I can export the just the full point cloud. So we're going to show that here in a second. So I'm going to do the inspection cloud one more time. And we're going to include where the structures go. Excuse me. We'll keep that to keep some reference and then bring this up a little bit. So I'm going to export this inspection and then export the entire point cloud. The inspection can be exported as an E57 LAS or LAZ. So that can come into Tekla. If I want to bring in an advanced steel or SDS2, actually SDS2 and E57 will come in. But it's already been georeferenced, so that'll fit in there. So I'll export this and it'll come in with those inspection colors. I will want to probably do the report with the preview here so that I know what those colors mean. It's going to be a lighter weight point cloud. If I want to bring in the full density, I'm going to actually just export an E57 from the export screen. So that's been exported, and I can bring that actually into SDS2 or Tekla, and it's just going to be a lot lighter point cloud. If I want to send the full detail, I would do the same thing as a non-structured E57, and this will send in actually everything, essentially the full density. So that inspection will be preview, the full density would be usually a little bit easier to look at and actually detail off of. So that's what that looks like when I bring in the full density in FieldLink. I can export that as well too as an E57 and bring those into Connect, Tekla, SDS2. If I want to bring them into Advanced Steel or an Autodesk product, I would need to bring that E57 into Recap. So if I wanted to bypass that, I could just export an E57. But these point clouds can be dragged and dropped. And so this is the inspection. I'm just going to rename this because I don't like it just as inspection or ScanJab1 inspection. Drag it into Connect. And then once the E57 is there, we'll drag and drop that into. And then convert them and share them. If I was in Tekla, I could stream directly from Connect. If I'm in SDS2 or Advanced Steel or Revit or AutoCAD, I need to download those and just insert them into those the CAD software. So we'll load those up and then show you what it looks like on Connect, and hopefully that's a good little workflow to show you how to use the scan data, align it to model, and export at kind of a full workflow. And so here we have just the connection pieces, and if we load up the model, yeah, everything's perfect. We can start to see that align. So this scan data can be downloaded and brought into SDS2 or streamed directly into Tekla. And we'll upload the rest of the full cloud. The inspection will also come through. So we can turn that on and we'll see a little bit more. But what's nice with that inspection is it's a lot lighter, so it goes quite a bit faster. And that can be brought in. But obviously the full detail between the two is going to be a little bit better with the full cloud there. So put that back in. You can start to see that's looking good. We get through that model. But yeah, if you have any questions, please work out to your nearest building point salesman, and we can walk you through this. But you can use scan data to check and confirm and design to, or check and confirm that what you designed is going to fit what's actually there, or just use it to start initially designing as well too. Create those control points if you want to lay back out the additional anchor bolts and foundations that are going to go in there. So we can actually see right here, those are looking pretty good. I'm probably going to need the full density to actually see where they're at, but we're going to need maybe a little bit bigger of a footer. But thanks.